The provided text discusses the nature of black holes, their gravitational forces, and their inability to consume objects including stars, planets, and even other black holes. It dispels those conceptions that black holes can consume the entire universe, or even a galaxy. Its explanation hinges on the fact that black holes only affect objects within a certain range, beyond which their gravitational pull is not strong enough to capture celestial bodies. Further, the text delves into several astronomical phenomena and discoveries. It describes unusual and mysterious energy bursts detected from the early universe, lasting 16 minutes, which challenges the understanding of astronomers. This event could be a result of gravitational lensing or something currently unexplained. It also mentions the strongest explosions in the universe, gamma ray bursts, in a particular long-duration burst, GERD 220,627, which lasted over 16 minutes. The text also uncovers the phenomenon of gravitational lensing, first predicted by Einstein's theory of general relativity. Finally, the text describes the observation of the remnants of a star 14 times the mass of the Sun, torn apart by a black hole. This observation, captured by the Chandra and Shin Newton observatories, provided a rare glimpse into the process of a black hole tearing apart a star and the resultant energy explosion. Here is the English translation. Black holes are famous for their immense gravitational pull, capable of swallowing stars, planets, and even other black holes. However, the question arises, can a black hole consume the entire universe bit by bit? The short answer is no. A black hole cannot devour the entire universe or even a galaxy, according to NASA. This is because black holes are collapsed giant stars, extremely dense to the extent that not even light can escape. The idea that a black hole can swallow the universe is based on the mistaken notion that they function like a vacuum cleaner, sucking in space. In reality, as Gravitational, a physicist of black hole studies at Rhode Island University explains, black holes only engulf things very close to them. In fact, black holes can only swallow objects that enter their spin region, beyond the point of no return. For example, the spin region of a black hole with the mass of the Sun would only extend about 3 km, and for a black hole with the mass of Earth, it would be just a few centimeters, about the size of your thumb. Despite their gravitational force, black holes do not swallow the stars and planets around them. They may cause these to orbit, like the black hole at the center of the Milky Way, but they do not engulf them. Professor of Astronomy at John Poland University. He explained in an article on the university's website that if our sun magically turned into a black hole of the same mass, our planet would not notice any change in gravitation affected in the. He said it would be very dark and cold, but the gravitational pull of the black hole at our distance would not be a concern. Alex at the University of California, Eli, mentioned to Line that it's important to note that black holes are quite small. For a black hole to likely swallow a star, the star must be aimed almost directly at the black hole. Over time, such cosmic targets may occur, but for the Sun to be swallowed by the black hole at the center of the Milky Way, for instance, would take an immense amount of time for the star's orbit to align with the black hole. Even the largest known black hole in the universe, a cosmic giant named Phoenix Ion, estimated at 100 billion solar masses, seems to exceed theoretical limits on how large black holes can grow. This limit arises from the fact that as giant black holes will naturally consume matter, they also emit a lot of radiation. This radiation heats and ionizes the surrounding matter, making it difficult for gas and dust to cool down and fall into the black hole, ultimately slowing the rate at which the black hole can consume. This self-regulation prevents black holes from swallowing entire galaxies, let alone the whole universe. The accelerating expansion of the universe also needs to be considered. As objects in space become more distant from each other, they are less likely to collide when captured by a black hole. If a black hole truly wanted to swallow the entire universe, it would need a major change in the direction the universe seems to be moving. So, you can rest easy at least regarding giant black holes. A mysterious energy explosion from the early universe puzzles astronomers. A 16-minute-long mysterious energy burst detected from the early stages of the universe could be the result of gravitational lensing or something astronomers yet explain. Gamma-ray bursts, the most powerful explosions in the universe since the Big Bang, are usually brief flashes of light, lasting only a few seconds to minutes. However, astronomers have now discovered a burst named Grub 220,627, lasting over 1,000 seconds, or just over 16 minutes. This unusual event was a powerful explosion from an unidentified source that occurred 2 billion years after the universe's formation. Although astronomers have not found any signs indicating the origin of the explosion is unusual, its duration and the nature of its two flare-ups have raised questions. When a giant star exhausts its fuel, it collapses before exploding into a massive supernova, leaving behind an extremely dense neutron star or a black hole. These subsequent explosions, and sometimes even collisions between neutron stars, create powerful gamma-ray bursts that can be detected by space observatories like the Fermi Gamma-Ray Space Telescope. To investigate the strange signal, astronomers studied the residual light from it, which is faint or less energetic light produced by the group of which shock ray from the initial explosion hits the gas or dust around the star. Knits the gas around the star. However, the residual light of group 220,627 only deepened the mystery. Unlike the lengthy duration of the explosion, it emitted normal bright light, resembling the lights produced by regular groups that last only a few minutes. Our observations and modeling of group 220,627 suggest a different origin from regular groups, the researchers wrote in their paper. Anyway, the most plausible explanation is that the group is a product of gravitational lensing, first predicted by Einstein's general theory of relativity in 1915. Gravitational lensing is the phenomenon where light from distant sources is bent by extremely large objects like galaxies and black holes, creating distortion and echoing the gleb signal before it reaches Earth. Researchers suspect the presence of a black hole or massive galaxy between us and the source of the gleb, elongating and duplicating its signal. However, to be more certain, astronomers need to describe this strange signal in greater detail. This will require more research and the discovery of other prolonged gamma-ray illusions. A chilling and unprecedented signal was caught by the Chandra and Sun Neutron observatories of NASA and the European Space Agency, respectively. They captured the terrifying remnants of a star 14 times the mass of the Sun, torn apart and scattered across the universe. These powerful X-ray observatories captured the horrific moment of Assassin 14, recently identified as the victim of a monstrous black hole according to Life. Before the team at Assassin 14 identified it as a flaming ghostly fire in 2014. Recorded by the ASIS project of Ohio State University with 20 robotic telescopes, scientists were puzzled about what it was. But now, the answer has been revealed. Dr. Drew Miller from the University of Michigan, the head of the research team on Assassin 14, said, "We are seeing the essence of what was once a star. Elements left behind are clues that we can follow to find out what kind of star died." This event is valuable in two ways. One, scientists had the opportunity to nearly witness one of the most severe cases of a black hole tearing apart a star. This type of star is extremely rare. It's also the most sumptuous meal a black hole has ever been known to have. Additionally, the main remnants of the unfortunate star that scientists saw were not the usual matter scattered everywhere. The super-powerful observatories inadvertently caught the core of the star still stuck in the black hole, indirectly looking inside the black hole. The power of the black hole and the terrifying energy of the star created an explosion that made observation easier. This is also the closest black hole star event to Earth captured in a decade, located in a galaxy 200 million light-years away. This recent observation of a black hole consuming a star provides valuable insights into your behavior and nature of black holes, their interaction with surrounding celestial bodies, and the immense forces at play in such events. The discovery not only underscores the destructive power of black holes, but also offers a unique opportunity to study the mechanics of these cosmic phenomena up close. The significance of such observations lies in their ability to enhance our understanding of the universe. Black holes, often shrouded in mystery, are key to understanding the fabric of space and the dynamics of massive celestial bodies. Observing a star's destruction by a black hole allows astronomers to gather data on the star's composition, a black hole's properties, and the physics of such extreme events. Furthermore, these observations contribute to the field of astrophysics by providing empirical evidence to support theories and models about the universe. They enable scientists to refine their understanding of how stars evolve, how they end their life cycles, and the role black holes play in the cosmos. And since the study of black holes tearing apart stars is not just about witnessing a catastrophic event, it's about piecing together the puzzle of our universe's history and mechanics. Each observation adds a piece to this puzzle, bringing us closer to a comprehensive understanding of the cosmos. These discoveries, while highlighting the vastness and complexity of the universe, also remind us of the continual evolution and dynamism of celestial objects. They underscore the fact that the universe is a constantly changing environment, with events occurring on scales and magnitudes that are hard to comprehend. In conclusion, the observations of black holes and their interactions with stars provide a fascinating glimpse into the workings of our universe. As technology and methods in space observation continue to advance, we can expect to uncover more secrets of the cosmos, further enriching our knowledge and understanding of the world beyond our planet.